Hello and welcome to the section 1.4 video today. Sorry about that. Today we're talking about literal equations, okay? And it's a very widely used application of solving equations. And so let's get right into it. It says that there are times in math that we're using different formulas, and it can be difficult to use the formulas the way they're presented. So like if we have an area problem and we're trying to find area of a triangle, the area formula is 1/2 base times height. And we want to look at a situation of what do we do if we're given the area and the base and we want to find the height. So let's say that I know that I have a triangle whose area is, I'm going to make up numbers so it could be ugly. Bear with it and we'll get through it. The area is 50, well, I guess for this example, we'll go kind of easy. We have 56 square feet, and we know that the base is 7 feet. I don't know if that's going to work out too nice or not. I know it should, but what if it doesn't? So one thing that we can do is we can use the area formula. We can say area equals 1/2 base times height, and we can put in the numbers that we have, right? We can say 56 is equal to 1/2 7 times the height. Okay, then we can solve that equation, right? And this is method one that we would typically use in our classes in any time we were asked this equation or this question. And I'll get to why we might use a different method in just a little bit. So then we're going to divide this by 3.5 on both sides. And it doesn't work out too well, does it? Where'd my, right there. 56 divided by 3.5. It does give us a nice answer of 16. So in this equation, or in this scenario, the height would be 16 feet, right? And there is another method, and the reason I talk about this other method is more in the sense of what if I had a bunch of different triangles and I knew their area and I knew their base, and I wanted to find heights of all these different triangles. This is kind of a complex process of solving an equation. And there has to be a better way. There has to be a way that if I was given a bunch of triangles, that I could do this in more of an expedited fashion. I wouldn't have to multiply specific numbers and then divide by those numbers, right? There's got to be a quicker way. So again, we were given this scenario that we want to find the height. So in this idea, in this second method, we're going to use what's called solving the literal equation, where we want to solve this equation for the height. What we're going to do is we're going to solve it with variables first, and then just be able to plug numbers in and solve it that way. And the beauty there is we had to use a calculator on this problem anyways. What if we could just use the calculator right off the bat? And here's what I mean. What if we solve this equation for the height and get this to say h equals some stuff? Okay, well, I can do that. And there's a bunch of different ways I can do that. Let's say first I want to deal with the 1/2. The 1/2 is being multiplied. So I would divide the 1/2. We don't really divide 1/2. We actually multiply by 2 in order to solve that part. So the 2 cancels with the 1/2, and I have 2 times the area is equal to the base times the height. And now I want to divide by the base. This is exactly what I did really when I solved this equation. Okay. Over here the base cancels with the base, and I get 2 times the area divided by the base is equal to the height. Okay? And so this is another way that I can say, here's what the height is equal to. Because using this method, and maybe I would rather rewrite it this way, which I usually like my main variable, I like to be on the left. That just feels a little bit better. But now dealing with this problem, I can say, all right, well, I know that the height is equal to twice the area divided by the base. Well, at that point, I can just use a calculator. 2 times 56 divided by 7. And I get 16. I get the same answer. Okay, this would equal 16. And we'd be good to go. And if I had multiple triangles where they told me the area and the base length, I could find the height very quickly with multiple times, multiple different triangles. And that's where this comes into play. I would say that this is more of a science application of equations, more so than math, because most of the time in math, I'm going to mix up what I don't give you, right? Sometimes I might give you the base and height, say find the area, or I'll give you the area and the height and say find the base, right? I can do all those different things, and we usually just do it in very isolated incidences. Okay, in science, they want to repeat experiments so many times, they want to repeat things so many times that it might be useful to have this equation written in a different way and deal with that formula written in that different way and find the same missing piece over and over again. That's where literal equations come into play most often, is in things like science. So when we're looking when we're working with equations that have multiple variables and we solve for that specific variable, we call that dealing with literal equations. Okay, let's look at how that might look in a math environment if I had things with multiple variables with some numbers scattered in there, and I wanted to solve those equations for, we're going to solve all these for y. Okay, they're all written in different forms, and we want to solve them just for y. So here's how we do that. Really, we're just solving the equation for y. So on this one, I want to subtract 2x from both sides. And that's going to actually cancel out over there and tell me that y is equal to, I can write this a couple different ways. I could write negative 2x plus 5, or I could write 5 minus 2x, and I could write it that way. That would be okay as well. The key here is that I can't combine the 5 and the negative 2x. Those don't combine together. Either one of these, I kind of like this one just because it looks like a way that we graph lines. I like that one a little bit better. And so this is just a skill, and this is something that we can do. Okay, and that's what we're going to do for all these. We're going to solve all these for y. Whenever I get an ugly equation like this, I do like to highlight what I'm solving for, just to keep my eyes on the prize a little bit. So in this one, I would subtract 3x, kind of like I did on the last one, but it was 2x. And so I'd have 5y is equal to, I'm going to stick with the 7 minus 3x. Okay, it's less symbols to write when I do that. And then I'm going to divide by 5. Dividing by 5 cancels it over there, and I'm going to leave it as that ugly monster of an equation of 7 minus 3x divided by 5. Because trying to simplify it any more than that is just more work. Because it would be like 7/5 minus 3/5 x. And that's not necessarily easier. Okay? There are times that I might choose to break that apart, but as a rule of thumb today, don't, because it's just more work that we don't necessarily need to deal with. Okay. Let's go ahead and look at this next one. Again, I want to solve it for y. I'm going to subtract the 12x. I'm going to move that 12x over. So let's say over here I have 13 minus 12x. And over here I have a negative 2y. I want to divide by negative 2. And I'm going to move my y over here. That doesn't really change anything. And I'm going to leave this as ugly as it is. Oops. That would be at minus 12x divided by negative 2. I'm just going to leave that like that, even though it's very ugly. It doesn't look good. But if I knew what x was, that's the easiest way to tell what y is going to be. Okay? These ones towards the bottom get a little bit trickier. Okay? There's some extra things that we have to do. On this first one, let's see, I want to subtract the 1 over z. Subtract the 1 over z. And I have 1 over x minus 1 over z is equal to 1 over y. This one's a little bit tougher. Okay? I don't just get to flip everything over. I wish I could. I wish it was that easy, but I don't get to do that. Yeah, this one's definitely one of those hard ones. I'm actually going to figure out what this would be. I'm going to extend the page because this one is going to get a little bit tricky. I need a common denominator with these two. I almost regret having this one on there. It's going to be xz is going to be my common denominator. That's as good as I can do. How do I turn the 1 over x into something over xz? I'm going to have to multiply it by z. How do I turn the 1 over z into something over xz? It's going to be x over xz. So this is going to be minus x. And that's going to equal 1 over y. Again, I almost hate that this one's on there. Now it turns out that I can flip these over. Okay? So I can say xz over z minus x is equal to this one flipped over, which is y. That's an ugly problem. Do me a favor, pause the video, and do these other two. They're not as bad. They're more like the ones from up above. Okay? So pause the video and give that a shot. Hopefully you had a chance to do that. These just turn into, sometimes there's a variable on both sides, sometimes there's not. This one, you got to do a little simplifying first. Okay? 7 minus 4x is going to be 3x plus 12 equals 36 minus 5y. We'll subtract 36 on both sides. So that does actually get subtracted from there. We're going to have 3x, and just to double check, I believe it's 24, or negative 24. These ones cancel, and I have a negative 5y. I'm going to divide that by 5y and call it good, or divide by negative 5, I meant to say. And I'm going to put my variable on the left because it just feels a little bit better. 3x minus 24 divided by negative 5. Call that good, even though it's very ugly. This last one, hopefully you did a little bit of work on this side, a little distributive property. 1/5 times 25 is 5. Negative 5 times 1/5 is negative 1. And then we get our 4x minus 9y plus 13. And so here we can move our y's to this side, move our numbers to the other side. So we're going to add 9y, subtract 5, and subtract 5. Subtracting, I'm dealing with y's and y's, numbers and numbers. And over here it looks like I'm going to get 8 y's. My 5's cancel, my y's cancel. 4x, and that looks like plus 8. And we'll divide both sides by 8. And I'm actually going to leave it there, even though it can be simplified pretty nicely. I'm just going to stick with the plan for today and leave it like that. It would actually just be 1/2 x plus 1, but I'm going to leave it like that. Okay, let's turn the page, take a look at what we have next. Oh, these were the ones that you were supposed to try. So go ahead and pause the video and you can try these ones. They're not that bad. So pause the video again, give those ones a shot. Hopefully you had a chance to do that, and hopefully we go with the easiest way to get y by itself. So you do have to kind of process what's going on. All I'm going to do on this one is move the 10 over and then divide by the -3. So I'll subtract the 10, subtract the 10. 2x minus 10 will equal -3y, and we'll divide by -3. I'm going to write my y on the left. That's what I like to do. And that looks like our answer there. This one, we want to subtract 3 on both sides. So we get 1/4 y is equal to -5x minus 3. And then actually, we can take this a little bit farther. I'm going to multiply this side by 4, and I'm going to multiply this whole side by 4. I'm actually going to distribute that one because it would make it look kind of nice. -5 times 4 is -20x's. -3 times 4 is -12. Okay. Then on this one, it's a move the number. I'll subtract 1 on both sides. I'll have 5x minus 3, and then we'll divide by 7. So y is equal to 5x minus 3 divided by 7. Okay, now here's where we would really use this. So those were all kind of practice for these ones. We want to solve it for y and then plug in the numbers. Okay, never mind. We're going to flip this around. We're actually going to solve these for x and then find out what x is when y equals -1, 0, 1, and 2. So we are doing this a little bit backwards. We're going to solve these for x this time. So we're going to subtract y from both sides, minus y, bam, bam. X is going to equal 15 minus y. And we want to figure out what x equals when y is equal to -1, 0, 1, and 2. So we're going to plug in y equals -1, 15 minus -1. I'm going to kind of note that here. That turns into a positive, so we get 16. When y is 0 rather, x is going to equal 15 minus 0, which is 15. And we'll see a pattern happening here. 15 minus 1 is going to be 14, and 15 minus 2 is going to be 13. So we see that that's a little bit easier to do that those multiple problems in one, as opposed to plugging each one of these numbers in for y and then solving each one of those equations. It's a little bit quicker and easier. Solve it for x. I'm subtracting y. Let's go 4 minus y. And then I'm going to divide by 3. 4 minus y divided by 3. And now I want to find each one of those. I'm actually going to put the y first and then the x over here. So -1, 0, 1, and 2. Some of these might end up a little bit ugly, like the first one. 4 minus y, 4 minus -1. 4 minus -1 is going to be 5. 5 divided by 3, we're just going to write that as 5/3. 4 minus 0 is 4, divided by 3 is going to be 4/3. 4 minus 1 is going to be 3. 3 divided by 3 is 1. 4 minus 2 is going to be 2, divided by 3 is 2/3. So that's what we get on those ones. Again, we want to solve for x. So I'm going to add 5y, 1/2 x. It's going to be 11 plus 5y. Instead of dividing by 1/2, I'm going to multiply by 2. I'm going to take this whole thing and multiply it by 2. I'm actually going to distribute that because it does make it look a little bit better and a little easier. 11 times 2 is 22. 5 times 2 is 10. And there we go. We can plug those in. Plug in my -1, 0, 1, and 2. And find out my x's. 22 plus 10 times -1. 10 times -1 would be -10. 22 minus 10 would be 12. Plug in 0. 22 plus 10 times 0 is just 22. 22 plus 10 times 1. 10 times 1 is 10. 22 plus 10 is 32. And I'll give you a really long time to guess this one. We're going to get 42 there. Okay. I want you to do that same thing for these ones. Shouldn't be too bad. Pause the video, give those a shot. Okay, hopefully you had a chance to do that. We're solving for x, remember. Hopefully you did that. And then we want to figure out x when y is equal to, I picked some different numbers here, -2, -1, 0, and 1. We want to find out what x is equal to. So on this one, you should have subtracted the y and subtracted the 2. Would have given you -y minus 2. So -2 is +2. Minus 2 is 0. The next one, -1 is +1. Minus 2 is -1. -0 is 0. Minus 2 is -2. And by now we should see a pattern. All these patterns actually work out every time. So it's kind of nice. Let's see, this one I want to solve it for x, so I'm going to add 5 first. Y plus 5. And then I want to divide by -1. Now, dividing by -1 really just switches all the signs. So we're going to have -y minus 5. It's kind of like the last one. -2, -1, 0, +1. I'm going to find our x's. -2 is +2, minus 5 is -3. -1 is +1, minus 5 is -4. I think you can probably guess. At least I would hope so. Okay. And this one's a little bit different. I am going to try something a little bit tricky here. First thing I'm going to do is add. Okay, I'm adding 3y, adding 3y. And we'll get -3x is equal to -9 plus 3y. Then I'm going to divide by -3, and I'm actually going to do that everywhere, which is something I haven't done yet. But it's just going to work out so nice on this one. I mean, kind of. Over here, I'm going to have x. -9 divided by -3 is +3. +3 divided by -3 is going to be -1. So that's what this one turns into. So not too bad. That's why I did that. You could have just written that as -9 plus 3y divided by -3, and you'd get the same answers. This way, it's just going to be a little bit easier. negative 2, negative 1, 0, and 1. And 3 minus negative 2 is going to be 5. Minus a negative turns into a positive. 3 minus negative 1 is going to be 4. 3 minus 0 is going to be 3. 3 minus 1 is going to be 2. Okay? So hopefully that helps make a little bit of sense of what literal equations are. Most of the time we'll see them with formulas, but there's only so many formulas that it's kind of nice to do this with. So in order to get a bunch of examples, I had to come up with some kind of tricky equations. We'll go over some other ones in class, some of these practice problems that are a little bit different, or a little bit the same. I'm more looking at the application type problems that are kind of nice, and some of these ones at the bottom that are more realistic of when you would do this. Okay, so I hope that makes sense. Again, make sure you write down any questions you have, and then have a great day, and we'll see you in class.